And our final JAG Talk today is the Academic Innovator. And Dr. Sen, who is Chair and Professor of Surgery and Director of the Indiana Center for Regenerative Medicine and Engineering, Professor of Biomedical Engineering by courtesy of Purdue University, and Associate Vice President of Research at IU, and the Associate Dean of Research for the School of Medicine, he notes the academic environment is not especially designed for innovators, yet increasingly more faculty are finding a way to do just that. So today, Dr. Sen will talk to us about the unique challenges and opportunities for aspiring innovators. Let's welcome Dr. Sen.
Thank you. Thank you, Steve. Thank you. So I'm here to share with you my story of the academic innovator. Humans traveled by feet, found animal back, enter the wheel, automobile, aircraft, spacecraft, the idea of time travel. The one constant difference that you have between each of those levels is transformation. And it is the human pursuit of transformation that is the primary driver of innovation. And we have plenty of that in academia. Now, when I was growing back, I was very curious about stories about innovators. And when I used to read those stories, a couple of things seemed to come back and back again. And one of those was the college dropout. You may have also encountered that. The college dropout, a very common feature of somebody that was a very successful innovator. And that enigmatic garage. If you put that enigmatic garage in the context of today, it could be that place sheltered from maybe the current regulatory compliance, you know what I mean. So now what we're dealing with, what we're discussing today is, if you somehow managed not to drop out of college, and you're not allowed to run your key experiments in a garage, can you still innovate? Now, academia, as we all know, is a very complex enterprise, and it has a particular mission. And raising innovators is not necessarily center stage in that mission. However, for those of us who are in academia, should we choose to, indeed, there are some barriers, but also there are some unique opportunities to innovate within academia. Now, one of the key features of people within academia innovating is that typically we tend to innovate in line with our scientific interest. So let me come to my own example. My interest is in the area of restoring tissue and organ function once that has been lost or damaged because of injury, disease, or simply aging. And I'll, in the interest of time, stick to two examples of innovation. One, that we reported a couple of years ago, where we came up with a silicon-based nano device, an electrical nano chip, that essentially can come in contact with the adult tissue for less than a second and can reprogram the function of the tissue. Recently, Dr. Francis Collins wrote a blog on this. The tissue technology platform is called TNT, or Tissue Nanotransfection. The point being that a large number of interdisciplinary experts came together to figure out a way by which a chip, hardware, could come into contact with perhaps a failing or injured organ tissue and reprogram cells in that tissue to acquire function that is needed to rescue the tissue. Now, in this one example that I'm about to cite, think of the adult skin. And you have this chip that comes in contact with your skin There are 10 pulses of electricity, each 10 milliseconds, a total of 100 milliseconds. The chip goes up, doesn't stay in your body. And now, skin cells, not the vascular cells of your skin cells themselves acquire a vasculogenic potential. And now those cells collaborate with other elements of the body to bring blood to that injured site, improving the healing process. That's one example. But that's not all that TNT does. Another example, also published, is another recipe, if you will, using the same platform, converting skin cell into nerve-like cells. So these are not only cells that express proteins that a nerve cell would, but they also have the electrophysiology of the nerve cell, meaning that they're functionally active. So what we were able to demonstrate is you can actually grow these cells on the skin as if the skin is a biological reactor under the surveillance of your own immune system, and actually grow these cells that you need, transplant them to the area that then needs it to correct a neural deficit, and can successfully do that. So the TNT platform, one example. The second example, when we were trying to rescue injured tissue, a key complicating factor is infection. We are not microbiologists, but that problem kept on coming. So what do? You use antibiotics. So did we. And what did we see? That these microbes are pretty smart in acquiring antimicrobial resistance. Now that's not new news. So you keep trying one after the other. So we huddled, and we thought, is there a way to manage infection in ways other than pharmacology? And through some study we found that microbial life heavily depends on its electrical environment. Microbes are electrically active. They establish for themselves an electrical milieu. If you now go and use biophysical ways of perturbing that milieu, you will successfully manage infection. So we came up in collaboration with the company, a product, got FDA cleared, came to the market, got DoD funded, currently in the clinical trial. Now, while we were doing all this stuff, we learned many things. I don't have time to share all of it, but maybe a couple. First, for those in academia trying to innovate, do not ever worry about whether you can solve the problem. Do not worry. The one thing that you need to worry about is this: whether this problem, if solved, makes a transformational difference. If not, very difficult to build a team. So step back, try to find a problem that you can brand as being transformative. Now, once that is a yes, meaning if solved, it makes a transformative difference, what you then want to do is define the problem. You define the problem, but don't stop there. Make sure you don't define it yourself. Get consumers, get industry, get legal, get the surgeon, get the mathematical modeler, get the biophysicist. All the people that are needed to solve that problem, get them on board. Without them, you will not have defined the problem completely. And defining that problem is a process that starts giving you answers to the solution, if that process is to be followed. Now, during this process, you will find that you have built for yourself a small team. And in the building of this team, there are a couple of things extremely important. One is the ability to pitch. You have a problem, you go to a surgeon, or you go to an electrical engineer, or you go to a mathematical modeler. You don't pitch it the same way. You must learn how to pitch such that the surgeon thinks that solving this problem would make a big difference to their domain. And that's an art. And once you have done that, you have the right type of team in place. Second point, and my final point in the interest of time, is over and over I have found that traditional sources of funding, research funding, are not really quite helpful. Sorry to say, but not really quite helpful to answer questions that are of transformative nature. Not helpful. I know many mechanisms, this and that. And as a peer reviewer myself, I can take some of that blame in that peer reviewers are inherently risk averse. It's too much of a risk. So in my case, and the answer can be different in other people's case, but in my case, each and every one, there are so far 6 companies that came out of our lab, and each and every one had some philanthropic donor that actually backed it up. And as this tissue nanotransfection technology, of which I discussed, when that came out, and actually when that was in the conception phase, the Wexner family, Columbus, Ohio, sat down, and thanks to that family, a significant check of about $1.5 million was written when I shared the story. So this art of how to raise money by telling a story to a potential donor is another component of that. So all these qualities taken together, and what I would put the last, as I said, is your ability to solve the problem. Oftentimes that stops you because you don't know how to solve it. Don't worry about it. I hope these words were helpful in some ways, and I thank you all for your attention. Thank you.